Hey everyone, this is just going to be a really quick overview of these 4 pages and with a little example problem for each one to get you started. On the page that you get, it should have on this very front page, it should be flipped, but over here there should be a space for your for you to write your name. Make sure to show all your work so I know that you aren't just copying someone else. You can grab a piece of binder paper or something and do the work there if you need extra space. On this very first page, this is review of percents and finding percents using proportions. So if I zoom in right here real quick, I'll do this very first one. So this right here here we have our proportion. This is the proportion, this part right here. And remember that a proportion is when you set up an equation saying that one fraction is equal or proportionate to another fraction. Now this works for percents because remember that the top of a fraction is the part and the bottom is a whole, and percents are, the word percent literally means per 100, so it's out of 100. You think of unit rates and it's like something per something, something per 100%. So whatever number is up here, whatever value is up here, is actually what the percent is. So if you remember, you find this by noticing patterns of multiplication. So I noticed that 10 times 10 is 100, which means that 7 times 10, I can do 7 times 10 to get 70, and I know that these are equivalent fractions then. And since 70 is in the numerator over 100, I know that 7 over 10 is equivalent to 70%. And once you find that, then we can look up here for 70, and I think it says each time your answer appears in the code, write the letter of the exercise above it. So that would be E was the answer to this. So I'm going to write E above 70. Here's a 70. So E. And I don't see any others. Next one. With this one, this is just order of operations problems. Something you might notice that is a little bit different about these is that they look a little bit more complicated. We have fractions and we have these funky, what are these? We did actually talk about these. These are called brackets, and sometimes they use brackets instead of parentheses. They do the exact same thing. You can actually notice in here we have these brackets. So these brackets are making a group. So this bracket, say you have to do everything in here first, but then you should be thinking that I actually have to do this first, because in this group, I have to still follow order of operations, and I need to do this first. The other thing you need to keep in mind is that a fraction bar is also making a group. So everything up here has to be simplified, and everything down here has to be simplified before you can actually take the top and divide it by the bottom to get this answer. So I'm actually going to do this one down here for you first, just so you can see an example. So that would be, the first step I'm going to do is this part right here. So that would be 3 times 5 over 2 plus 3. This whole thing is in brackets still, times 6. The next thing I'm going to do is, it's actually easy enough to do both of these, I think, at once. So I'll do those both at once. So 3 times 5 is 15. That's going to be over 2 plus 3 is 5. And that's kind of in its little brackets, times 6. And 15 divided by 5, remember that you still have to do this first. Everything in here has to be simplified because it's still in a group in these brackets, which do the same thing as parentheses. And now that the top and the bottom of my fractions simplified, I can actually divide this. So 15 divided by 5, I'm doing this part next. 15 divided by 5 is 3. and that's the only thing left in there, times 6, so that's going to be 18. So 18 is the answer to this one, and so you go back up here, and that letter was A, so I'm going to put A's in above all the 18s. A, find the others, you get the picture. Next one. This is some combining like terms. So it looks like there's a lot of these, but there's actually not that many. This is actually 4 different sets in these different boxes. So it's matching. All of these answers right here should match to these answers. These guys here should match to these. These should match to these. And these you can match to these. So remember, as I'm doing this, I'll actually do 2 of these because we've done a little bit less of this, but I am noticing on this first problem S that I have 5x and I have 3x, and those are like terms, and then I have a 2. So I can actually add together the 5x and the 3x to make 8x, and then the 2's by itself, so plus 2. And that is going to be down here at 17. So this is, down here at 17, this is the answer to S. I'm just going to put an S right next to it so I can keep track and fill things in later. And let me do another one. Let me do O for you. So O, I have 9x is one term, and 7x is a like term because it has the same variable. And then I have 3 and 4. Those are like terms. So that could be simplified to 16x plus 7. So 16x plus 7, that is 23 right here. So that would be O. And then you're going to take those answers as you do that, and you're going to put in the, so in 17 you'd put an O, in 23 you'd put an O, in the box 17 down here you'd put an S. So I think it's easier just to write the letters next to them as I match them up and then go through at the very end and fill this out instead of trying to go back and forth all the time. These ones down here are the same things, even though they're more complicated. You're just looking for similar terms. So the Z variables end up making one term, and the U's make one term, and just the constant numbers represent one thing. Remember that a variable by itself represents one of them. So U is the same as 1U. And no one. And this is the same thing as the page before, but it requires distributing first. So not too much more complicated. Definitely I would do the other one first. But for an example, this one right here, I'll do these ones because these ones are actually a little bit more complicated. But here I'll do this one. So I need to distribute this first. I need to distribute this guy first. So I'll actually try and use different colors so it helps you remember what we're doing. So this 5 times 9k would be 45k, and then the 5 times 2 would be plus 10, right? And then plus, and then the 8 times 4k would be 30. Oh, sorry. I'm going to do the 8 times 3 first because it's closer. So 8 times 3 is 24. And then the 8 times 4k, 32k, right? So I distributed, and now I can actually add the like term. So I can add the 45k and the 32k, which would be 77k. So 77k, and then I have 10 and 24 this 10, and this 24. That's 34, so plus 34. And you can go find that. Hopefully I did that right. There it is, right here. So that one is E. So this one will take a little bit longer, but by the time you're done with this, you will be masters of distributing and combining like terms. If you finish all 4 of these and you still have time left in the week at the orange tables, then head to somewhere in your Google Classroom in Math. There is actually instructions for something else you could do. So have fun.